Welcome to the first video on Chapter 7, which is Special Parts of a Triangle. We're going to start with 7.1, which is on bisectors. So, it says in the book that the perpendicular bisector of a line segment is a line passing through the midpoint of a segment, such that the line is perpendicular to the segment. So, they give this image right here of segment AB with line K going through it. And the way that we can tell that this is a perpendicular bisector is that it divides this in half. So when we look at it, this side's going to be equal to this side, and it's perpendicular because this is 90 degrees, and this is 90 degrees because it has to equal 180, and this is also 90 degrees, and this is also 90 degrees, and so this is going to be a perpendicular bisector of line AB. Now, it also goes on to talk about angle bisectors. And it says an angle bisector of an angle is the ray that divides an angle into two equal angles. So it gives this figure right here and says that ray M right here divides angle AOB into two equal parts. So this is equal to this right here. So that's how you know that it's an angle bisector, because this line right here divides this whole angle right here up into two equal angles, and so since they're equal, it's an angle bisector because it divides it in half. So I'm going to demonstrate more about this with two problems from section 7.1, and we're going to start with problem 7.2. And in 7.2 it says, in this problem we will show that if AC is equal to BC, then C is on the perpendicular bisector of line AB. And so it says, let C be a point such that AC is equal to BC, so I drew that out here, and let M be the midpoint of AB, so I've drawn that there. So that covers the draw a diagram part for part A. Now it says draw CM, so then use congruent triangles to prove that line CM right here is perpendicular to line AB. Why does this mean that C is on the perpendicular bisector of AB? So the way that we're going to do this is think, okay, so congruent triangles. What are the ways we can prove this? So we look at this here and we already have this side's equal to this side's equal to this side. So we're trying to prove that triangle ACM is congruent to triangle BCM. Now the way, since we already have two lines, we look at, say, okay, we need to find either an angle or a side, and we have this side right here, and since CM is equal to CM, obviously, then we can just say, okay, so this is equal to itself. So these two triangles are congruent by side, side, side congruency. And so since they're congruent, that means that this angle right here is equal to this angle right here. And since two angles this is a straight line, these two angles added together have to equal to 180. 180 divided by 2 is equal to 90, so these are equal to 90, each of these. So we can say that line CM is the perpendicular bisector of AB. And that gives us the definition of the perpendicular bisector, which is the perpendicular bisector of a segment is a straight line consisting of all points that are equidistant from the endpoints of the segment. So since it could be like, a point could be right here, as long as this line's equal to that line, any point on this line right here, all these points added together are the perpendicular bisector of this line right here, AB. And so now we're going to talk about problem 7.4, which is on angle bisectors. Now, for 7.4, it gives you a figure that looks something like that. And it says C is a point inside angle XYZ, such that C is equidistant from ray YX and YZ as shown right here. Show that C must be on the angle bisector of XYZ. Now the way that we're going to do this is think, okay, so angle bisector means that it's on the line that splits this angle in half. So we draw a ray a little better than that. We'll draw a ray like this, straighter. Then we'll say, okay, how can we prove that it makes it so this is equal to this and C is on that line? So we prove it by using congruent triangles. So we try and prove that the triangle PYC right here, PYC, is congruent to triangle QYC. And you're doing this because if these two triangles are congruent, then you can prove that this angle is equal to that angle, and that makes it on the perpendicular bisector. So you already have that CQ and PQ are equal to each other, and PC, sorry, are equal to each other, like because it was given to you. Now we need to find another way to make this true, or prove that it's true. And the way we do that is by saying, okay, so YC is equal to itself because YC is equal to YC. And now we have one leg in the hypotenuse. And a way of proving congruency is hypotenuse-leg congruency. So since we have the hypotenuse is equal to itself and one of the legs is equal to itself, it must mean that these two are equal to each other by hypotenuse-leg congruency. So since these two triangles are congruent, that means this angle right here is equal to this angle right here. So C is on the angle bisector of XYZ because we used congruent triangles to prove that this angle is equal to this angle. And so it gives us the definition: the angle bisector of an angle consists of all points that are equidistant from all sides of the angle. And so that's sort of like the definition that we got for what a perpendicular bisector was. This is just for an angle, and that's how they show you what it is using this problem in 7.1. And now I'll move on to 7.2.